All right, we're not always just going to have rectangles. Now, you're going to have more than 4 rectangles. You're going to have more than some of that stuff. That's crazy talk, right? Just to have a few tiny little things here or there, and you get patterns that happen. So instead of drawing out rectangles, we can get the sum of powers of integers. Instead of drawing out our rectangles, if we know how many there are, this is a pattern that happens. If I have just a constant, just a number, that's all a constant is here is just a number, then it's going to be C, whatever that value is, times the number of rectangles you have. If it is K here, if it's just some value K, if K is my variable, then this is the pattern that happens for how many rectangles you have. If I have a squared pattern, then this is the value. If I have a cubed pattern, then this is the value. All right? So that's the kicker. Instead of going through and taking the area every single time that we have, these are shortcut formulas. For these patterns. Now, you know, I'm always like, I'm never going to give you any formulas. Am I ever going to give you formulas? Right? Right? I mean, that sounds like a broken record with that. All right. But listen up, people. You do not have to memorize these. I will give you these formulas. What? And here's the reason why, because you're not going to use them again after this. All right? It's good to see the pattern. It's good to have these ideas. It's good to learn how to do these summations, because you're going to do a whole lot of summations in Calc 2. That's why we're spending our time doing this. Yes, you're not going to use these formulas again for these patterns. However, the concept of a summation, that's going to come back. That's why we're doing this. All right? So the concept of summation and making sure you know how to do that, you will need to know how to do that. So we'll practice doing that with these formulas. Okay, I'm going to do a couple of examples here, and then we'll call it good. So here's our first one. Let me zoom this in here just a tad. 5.1.49 is what we're going to look at here. And this is F. There's a lot of parts to these. It doesn't have to just be a K. If I have J equals 1 to 3 of 3J minus 4. It doesn't matter. As long as your variable matches whatever it is that you're using as a variable in the base of your sigma, that is fine. Now here's what's going on with our shortcut formulas. We have a J. With this J, that is going to send us to just a variable. All right? With this number. This number here, well, let me change my color so you can see the difference between the two. My number here is going to send us just to the number. So we have two things that we're looking at. Okay, well, let's plug it in. Here, if I have 3 coefficients, just a coefficient, nobody cares. Because this also right here is n. Right, n equals 3 is what we're looking at. Okay, that's the n of my formulas. All right. What are we on? Blue. Let's go back to blue. So here, I'm going to scoot this up just a little bit if I can make it work. We've got 3, because that's just my number here, 3, and then I plug into this formula. So I've got n, which is also a 3. So I've got 3 times 3 plus 1 over 2 minus, and then I'm plugging into my formula right here. 4 times n. So minus 4 times my n, which is a 3. And then you literally just do work. That's it. I'm going to make this bigger. So I've got 3 times 4 times 3 is 12 divided by 2, which is 6. minus 12. So 18 minus 12 is 6. It's literally that easy. There is no catch here. There is no other shoe that's going to drop. There is no other ball that's going to drop, right? I know you guys look for that. There isn't anything here. I give you the formulas. Write these down in your notes, right? So write these down in your notes so that you have them so you can do your homework on your quiz. This is something I would give you. If I put these on your test, this is something that I would give you, all right? So heads up on that. Okay, let's do one more here real quick. The same thing, 49. We're just going to do G. It is, I've got P is equal to 1 to 5 of 2P plus P squared. Now I'm not going to flip back and forth between the pages. I've got just a regular P variable and I've got a squared. So I know that K is going to go from 1 to N of K is just going to be N times N plus 1 divided by 2. I'm just writing the formulas over here on this side just so that you can see them. K squared is N times N plus 1, 2N plus 1. Oops, I forgot my 2. All of that is divided by 6. Okay, so I've got my N is equal to 5. I've got my first term and I've got my second term. So we're just going to plug into our formulas. So this is 2 times the regular P formula here, which is going to be, my N is 5 times 5 plus 1 divided by 2, plus my P squared, so I've got 5 times 5 plus 1, 2 times 5 plus 1, all over 6. All right, then clean it up. So make your life easier. 2 divided by 2 goes. So I just have 5 times 6 up here, which is 30. Plus, again, 5 plus 1 is 6, so cancel it out. That's all multiplied, right? So if you multiply it, then multiply that out. So now I've got 11 times 5, which is 55. So my whole thing is going to be 85. That's it. That's all there is to it. That is 5.1. So go practice that, and you can rock the socks off this stuff. Nice job, guys. Just that easy. Setting the groundwork, setting the groundwork.